learn like a pro.
Okay, let's be honest. Chemistry calculations can feel like you're totally lost in a maze, right? You're trying to get from grams to liters or from concentration to particles, and it just feels like there's no clear path. But what if I told you there's a secret map, a kind of universal blueprint that connects everything and makes it all click?
So here's that map. Look at all these different concepts on the outside. We've got mass, particles, gas volume, concentration. They all look like these separate disconnected islands, don't they? But what's that right in the middle? What's the one thing connecting them all? Yep, it's the mole. This is the central hub, the grand central station of chemistry that makes every single one of these calculations possible.
And here's the really crucial part. There are no shortcuts. You can't just zip from one island to another. I want you to think of the mole as a central toll booth on a massive highway. You can't just drive directly from the city of, say, mass over to the city of gas volume. Nope. You have to pass through the mole toll booth first. You absolutely must. This is, without a doubt, the single most important role in stoichiometry, which, by the way, is just the fancy term for figuring out how much stuff you're making or using in a reaction.
Okay, so you're probably thinking, great, I get it, let's start calculating. Ready to jump in and use those formulas? Well, not so fast. Hold on a second. There's one critical step, a checkpoint that almost everyone forgets that you have to clear before a single calculation can even begin.
And this is that checkpoint. Look, before you even think about plugging numbers into a formula, you've got to pass through these critical unit conversion gates. Why? Well, it's simple. A perfect calculation with the wrong units is a completely failed calculation. It's worthless. And the most common trip-up? It's right here at gate 1. People forget to convert cubic centimeters, or cm cubed, to cubic decimeters. You always have to divide by 1,000 first. Get that right, pass through this gate, and then you're ready to roll.
All right, units are sorted. Let's take our first route on this map. We're going to fire up what I call the 6-step engine. It's this super reliable process that can solve pretty much any stoichiometry problem you can imagine.
So here's our first challenge, a classic mass-to-mass conversion. The problem is this. We're heating 8.4 grams of magnesium carbonate, and our mission, should we choose to accept it, is to figure out the exact mass of magnesium oxide that gets produced. Simple enough, right?
And here is that engine. It's a universal 6-step process. Step 1, you just identify your data, what you have and what you need. Step 2, and this is the big one, you convert to moles. That gets you to our central hub. Then you balance the equation, find the mole ratio. That's kind of like the gear connecting the two sides. Apply that ratio, and then the last step is just converting out of moles and back into the unit you actually want. You just follow these steps in order, and it's going to work every single time.
Okay, let's watch this thing in action. It's like a pipeline. We start on the left and feed in our given value, 8.4 grams of magnesium carbonate. Boom. First step, we convert that to moles, our ticket to the central hub. So 8.4 grams divided by the molar mass gives us 0.1 moles. Perfect. We're at the center. Now, the balanced equation tells us the ratio is just 1 to 1. Easy. That means for every 1 mole of our starting stuff, we get 1 mole of our product. So our 0.1 moles just becomes 0.1 moles on the other side. Simple as that. And the final step? We just convert back out of moles. We multiply that 0.1 moles by the molar mass of MgO, and we get our final answer, 4 grams. See? It's just a logical flow. In, across, and out.
All right, that was our first route. Now let's tackle a second common scenario. This time, instead of a pipeline, we're going to visualize it as crossing a bridge, the titration bridge. But don't worry, it's really just another way of thinking about the same journey through our central mole hub. So here's the setup for this one. We've got some sodium hydroxide, and we know its concentration and volume. We're going to use that known stuff to figure out the unknown concentration of some sulfuric acid. Yep, you guessed it, it's a classic titration problem.
Now, the core idea here is exactly the same. We're just picturing it as a bridge. See, on the left pillar, that's our known substance. Our first step is to calculate its moles, getting us onto the bridge. Then we cross the main span. What is that span? It's the mole ratio from our balanced chemical equation. Once we're across, we're at the right pillar, our unknown. And step 3 is just to calculate whatever we're actually looking for. Known, ratio, unknown. That's the path.
You know, there are actually 2 ways you can cross this bridge. You can take the scenic route, what we call method 1, using first principles. That's the 3-step process we just talked about, and it's awesome for really deeply understanding what's going on. Or you can take the expressway.
Method 2 is a direct formula. It's amazing for speed, especially when you're in an exam and the clock is ticking. Let's check out how they both get you to the exact same destination.
And here you go. Here's the proof. Both methods land you in the exact same spot. Over on the left with method 1, you can see us working it out step by step. We find the moles of the known stuff, NaOH, then we use that crucial 2-to-1 ratio from the equation, and finally we solve for the concentration. Now look at the right. Method 2 just plugs everything into one clean formula. Yeah, it's faster, but it's running the exact same logic under the hood. And the result? Check it out. No matter which route you take, you get the same answer. The concentration is 0.060 moles per decimeter cubed. Both paths work.
So, after all that, what are the big takeaways? It really just boils down to 3 golden rules. Number 1, balance before you build. Seriously, that balanced equation is your entire blueprint. Don't skip it. Number 2, you got to find the moles to cross the bridge. Remember, you can't compare grams to liters directly. It just doesn't work. You have to go through the mole. And number 3, trust the engine. This framework, this system, it's universal. It'll get you through.
So you see, that maze of chemistry calculations, it's not so confusing after all, is it? It's actually a really elegant, structured system with a central hub and super clear pathways. You now have the blueprint. You've got the MEP. So the only question left is, what are you going to build with it?